Good morning, everybody. How's everybody doing? Did anybody have a little rough night last night? We're not going to talk about those stories today, but what we are going to talk about is robots, 5G, wavelength, software, developers, you name it. Welcome to the session. I'm Elise Neel. I'm the Senior Vice President of New Business Incubation at Verizon, and I am joined by my esteemed colleague, Mr. Robert Belson, who heads up developer relations at Verizon, specifically for our mobile edge compute platform and our partnership with Wavelength.
That's exactly right, Elise. And today we're going to be talking all about how you can build smarter applications at the edge with Verizon 5G Edge and AWS Wavelength. And we're also going to showcase how Verizon will be connecting and deploying aerial and ground robotics for Industry 4.0 customers. But also, as developers, if you want to build this type of stuff from scratch, we're going to show you exactly how to do so, the architecture, but also what network intelligence is going to look like for the future of the edge.
So with that, we are going to dive into Verizon-specific use cases. You're going to see an opportunity to understand how you can get involved. And we're going to talk about how network intelligence is going to help power the future as we think about Verizon's 5G network, mobile edge compute, wavelength, and intelligent software. So we're going to dive in. Y'all ready? I'm going to need some, this is an audience participation session. Give me some head nods. All right, okay. Here, thank you in the midsection. All right, so at Verizon, we always start with the customer in mind and trying to understand how do we think about working backwards from the customer. I don't know if you know this when you woke up this morning, but you're kind of on the cusp of a brand new industry change. We really believe we're at the beginning of the fourth industrial revolution, or sometimes we call it Industry 4.0. And this is about the adoption in enterprise from kind of moving from just connecting your devices into automating your processes, and then from automation all the way into autonomy. And what's been such a challenge for enterprises today is that they're all bought into this vision. Everybody wants to reduce the labor squeeze. They want to figure out how to create more efficiency, how to generate faster time to insight. But the challenge is that they've got these 5 core problems that prohibit them from doing that today. Everything from, they've got a wide variety of hardware from a variety of OEMs, none of which communicate to one another. There's no interconnectivity, there's no interoperability. They've got legacy applications and proprietary protocols that just no communicado between each of those different components. In addition to that, there is just like stupid amounts of data that they've got to sift through. They need high reliability, high availability. If you're going to move to a lights out factory, if you're going to move into true autonomy, you can literally not have that connection go down or that data not be accessible. It's just not an option. So as we think about each of these challenges that enterprises are facing today, we get pretty pumped up about it because we see that underneath all of this is an opportunity for 5G to change the game. 5G has massive bandwidth, it provides low latency, particularly when you add in mobile edge compute. It's got extremely high reliability, it has energy efficiency and several other functions that make these challenges now an opportunity for us as we think about moving forward. And so what we're going to talk about today is like the peanut butter and jelly sandwich of how we kind of move forward. We think about the combination of Verizon's 5G network. We think about the application of mobile edge compute and our partnership with AWS Wavelength and intelligent software that all comes together to help produce an end-to-end solution for the customer. We believe that this combination, where it's not just about Verizon, it's about the developer communities, the ecosystems, and big partners like AWS, come together and help us provide, again, those opportunities for the future. So today, I'm going to talk to you about 2 specific areas where Verizon and AWS have partnered to power Verizon's specific experiences in the area of robotics. Why robotics? Because these are some of the hardest challenges and the most intense machines that exist out there. We figured we'd start with the hard stuff first because that's kind of just like our jam, right? And so I'm going to show you use cases for robotics on the ground and in the air, and we're going to talk about this same combination, this 1, 2, 3 punch of kind of packing it together and the opportunities that exist for you as developers. All right, first I'm going to talk about what's happening on the ground. So let me set the stage for you. Verizon has invested over the last 3 to 4 years heavily in robotics. On the ground robotics, we're talking about a quadruped, so 4-legged robots. We also call them dogs. We have an affectionate name. We call them Bottweilers inside of my team because that just feels cute. We also do wheeled robots. We have fixed robots. And then obviously we'll talk about every kind of form factor for the skies as well as we think about the drone space. But in those investments today, if you're not familiar with robotics, they're basically just incredible mechatronic machines that require 100% of the brain to be on the machine itself. All the compute, all the storage, and all the preloaded AI algorithms that you think that that machine could need to perform also have to be preloaded onto that machine. Most of them are not connected to any connectivity today, and they basically operate as like individual entities inside of an ecosystem, whether that's a construction site or a manufacturing floor or a healthcare facility or a stadium. It really just doesn't depend, it doesn't really matter where it is, but they're kind of out of the box and independently isolated. We see an opportunity to change that. We see an opportunity to actually create broader streams of scaled robots that begin to communicate and understand their context, and to connect not only with the network, but to all of the other components that are connected to the network as well. So I'm going to show you what we're doing now. I'm going to walk you through a use case that we actively deploy today as we think about securing our most secure sites as a Verizon kind of entity, whether they be our major office buildings or central offices. Perimeter security and understanding those kind of inspection criteria are critically important to the work that we're doing. Traditionally, what happens today, particularly for elements where a car has been parked for more than 24 hours, this flags the no bueno for us, right? Our security teams say, hey, listen, something's up. Either like somebody is sleeping in their car, someone's looking to do harm, or maybe somebody just needed a designated driver and ended up it's benign and they're just parking their car overnight. But you never know when you approach a car that's been parked for kind of longer than 24 hours. So I'm going to walk you through an intelligent use case that takes the Verizon 5G network, the mobile edge compute powered by Wavelength, and our intelligent software through our robotics business technology team, and putting that all together to create this interoperability and interconnectivity. All right, here we go. So what you're going to see. First, what ends up happening is this red beacon that you see is a CCTV camera. That CCTV camera, not a human operator, identifies that a vehicle has been parked for more than 24 hours in the parking lot. Automatically, it then sends the mission and the location coordinates to the robot. The robot says, great, let's rock and roll. That robot then autonomously navigates to the point of interest, not really knowing what it's going to find. As it's navigating there, it's kind of beginning to understand and build the model that it will environmentally, or create the environmental context around that vehicle. Now, it doesn't know what kind of vehicle it is. It doesn't know the points of interest. And so as the robot is walking around that vehicle, it is dynamically building a digital twin as it's connected to the 5G network. This digital twin begins to come together to say, hey, listen, this is a Toyota Tacoma. It's a truck. It's taking the computer vision algorithms, it's looking at the license plates, it's looking at the format of the vehicle, and then through that saying, hey, listen, because it's a truck and because we know this form factor, these are the areas of interest that we're going to need to go check around. First, the robot goes in and it takes a look inside. Is there a human inside? Is there something that's hot inside? It also looks underneath the carriage of the vehicle. Is there something of interest underneath here that we need to be conscious about? But perhaps most intelligently, it also knows that because it's a truck, it should check the truck bed, which is a different motion for the camera. It's a different motion for the robot. In that, it identifies a package in the back, and through Wavelength, downloads the application in the AI algorithm to deploy thermal imaging. Because when you have a package, you need to know what's inside the package. Is it hot? Is it explosive? Does it have any of the characteristics that would cause us harm? Thankfully, in this particular instance, our Boston Dynamics Spot robot says, all clear. It goes through the inspection criteria, and it heads back to its dock. Now, what's interesting about this is not necessarily the fact that we're using a robot for a human task, but it's this intelligent learning that's happening through the deployment of these AI libraries on Wavelength. This dynamic self-learning, self-healing, self-adapting component over the 5G network allows for all of this intelligence and these decisions to happen on the fly. Remember, there's no human operator in the loop here. 100% is software and networking happening at its finest. In addition to that, obviously, all of the video is stored in the application. It's referenceable and searchable for the future. All the algorithms can be kind of audited to make sure that we're always maintaining ethics and reliability kind of throughout the process. But this is just one example where no longer do we have a human operator in the loop. 100% of this can be performed autonomously, and it can also be dynamic. You don't have to preload, okay, if it's a Toyota Tacoma, these are the inspection points. If it's a Honda Civic, it's this. If it's a Lambo, we're looking at these other components. That's the world we live in today. We see an opportunity, again, with that three-pronged approach. You got your network, you have your mobile edge compute, and you have your software coming together to change the game. All right, that's the ground. Let's take to the skies. So when we think about drones in general, and whether, again, it's a quadcopter, a fixed wing, it doesn't really matter. Whatever the form factor is for the sky, the same kind of applications apply. Drones are absolute data hogs. They're a wee bit selfish when it comes to the network. Generally speaking, an average flight potentially could produce terabytes worth of data that isn't really going to be sustainable over a 4G connection. In addition to that, the ways that we inspect our network today, and y'all look like a real spiffy crew this morning. I'm certain y'all are all Verizon customers and appreciate the most reliable network. And the reason that you do is because we inspect our infrastructure constantly. We have thousands and thousands of tower sites, and we need to make sure that there's no overgrowth, no vegetation, no bird's nests, no natural disasters, no rust, et cetera. And that requires us and our network assurance team to basically go out and to search and assess and inspect those towers all the time. So today what happens is you roll a bucket truck, that individual goes up into the bucket, they take a wee look around, there's a visual observer for safety on the ground, they maybe snap a couple pictures and kind of go back in. Well, Verizon over the last couple years has actually deployed the largest enterprise drone fleet we believe in the world. We have hundreds and hundreds of licensed drone pilots that inspect our infrastructure daily from our network assurance team. And even when we're using drones, there's a challenge. The technician goes out to the site, it deploys the drone, it goes up, it surveys the infrastructure, and that's great because we've removed the bucket truck piece. We've removed the extra kind of safety concern as someone is hoisted way up in the air. So they conduct their mission, they land the drone, they pull out the SD card, they drive back to the site, drive back to the office, they then input the SD card, and now their analysis can begin. And this takes hours and hours to actually understand, well, was the rust there the last time we looked at that site, or is that new? Is that bird nest old? Is that a habitat we need to protect, et cetera, et cetera? What we're now doing is we're going to shrink that down to minutes, from hours to minutes. And we're doing that by, again, using this same formula. As we think about the network, mobile edge compute, intelligence around self-healing, self-performing, self-adhering kind of components around the intelligence, and our software. In this case, we're powering this mission that I'm going to show you in a second through Verizon's owned and operated aviation management platform, Skyward. And so as we, again, kind of think about this sandwich that we're pulling together, we're hoping to provide enterprise customers with this end-to-end capability. So as we start to roll the video, what you're going to see is kind of a normal course of action. These are our typical infrastructures. If you're not familiar with the makeup of a cellular tower, we typically have 12 to 20 different radios inside that tower. Well, we have now partnered with Parrot, which is a drone manufacturer. We are launching the world's first cellularly integrated drone out of the box. In this tiny little white packaged dove, you get your drone, which is amazing, with autonomous capabilities, which we'll see in a second. You get automatic connection into the most reliable network, which is Verizon's. You have all of the aviation management and software capabilities of Skyward, and you have your data modeling, your analytics, and mapping all prepackaged and ready to go in one easy out-of-the-box solution in a hot little white briefcase that you and your technicians can rock on for your inspections. So what you're going to see here is a dynamic inspection. The technician rolls to the site and says, all right, I need to inspect this tower. I'm going to use the platform to identify the 5 different inspection criteria that I'm looking for this particular mission. When I do that, it triangulates my location and it pulls up a reference architecture from a digital twin from the last time we surveyed that site, because you want a before and after view. In that dynamic structure, we're also making sure that weather conditions are great, that we do not need specialty waivers from the FAA, that we're plotting our mission plan, and that all of the conditions and safety certifications are ready to go. Inside the platform, we've now launched our mission plan, and the drone will launch and autonomously fly this mission using the network, mobile edge compute for intelligence, and the Skyward software platform. As it goes through, you see it's now beginning to identify its inspection points. It goes through the location coordinates. It has now attached itself, the drone from a location perspective. It's kind of dialed in and clicked into the digital twin. And it goes and it seamlessly executes its mission. Now on the ground, the technician is hands-free. Now he's got his joysticks available because that's what's required for FAA today. But the reality is this drone is performing 100% autonomously. As it goes through, it's checking to say, was this rust here before? How do I analyze whether or not this passes the inspection? It's taking all that same data feed, and it's storing it live inside the platform for anybody to collaborate with, really anywhere around the world. As the drone completes its mission, it runs through the inspection report and says, fantastic, the tower is ready to rock, and the drone lands safely in the technician's hand. Off we go to the next site. We've now taken hours, and we've shrunken it down to minutes, as that drone is autonomously and intelligently pulling down those AI algorithms to understand the before and the after, or the before and the present. It's trying to understand, the size of rust and any other kind of characteristic that could prohibit you having the best cellular experience anywhere in the world, because all of you have that, because again, you're all Verizon customers. And again, we're kind of shortening that time to insight, which is fantastic. When we think about robotics at Verizon, we're really spending a lot of time in this area because we see that this is an area that 5G can meaningfully impact. We're taking the drone and the robot intelligence grounder in the air, and we're moving those brains, that command and control, that compute, those AI algorithms. We've taken those brains and we've moved them inside of the 5G network and allowed them to be deployed on mobile edge compute in 10 milliseconds or less, oftentimes. As we think about the power of that speed, that bandwidth, that ultra reliability, that security, et cetera, this is why we're super nerded out about robots, because we see this providing a meaningful acceleration to those enterprise problems we started with today. How do you get to interoperable scale? How do you start thinking about powering thousands of robots in the sky? How do you think about equipping a lights out factory floor with maybe 10,000 or more different movable parts and pieces? How do you orchestrate that design together? How do you keep them safe? How do you keep humans safe? How do we think about the safety and security of that data? All of that are just some of the reasons why we're really excited about this combination. And frankly, our partnership with AWS Wavelength is a really big one to help enable that vision. So you've heard me drone on. Haha, anybody? Nobody, we don't get it. You guys are gonna need to pep up today. You've heard me talk about what we're doing at Verizon, but the reality is that you have an opportunity to get involved. So I'm gonna get my homie back up here, Robbie, who's gonna talk to you about how you can start accessing some of this data. Take it away, Mr. Belson.
Thank you, Elise. All righty. Those were awesome demos. I don't know about you. I thought that was really cool. But now you want to build those demos on your own. It all starts with the infrastructure. It starts with the network intelligence. And we're going to break down each of those components, starting with the fundamentals. I think where we need to start is really what is mobile edge computing on AWS? What is Verizon 5G Edge? How does this all work? And in the process, let's learn a little bit more about 5G networks. So mobile edge computing is really all about, certainly in the context of AWS, bringing the best of AWS compute and storage to the edge of Verizon's 4G and 5G mobile network. And so at the highest level, we're here in Vegas today. If you're consuming a mobile app, here's what's probably happening. Your mobile application today, all that data is connecting to a 4G or 5G radio, and all those radios for a given location are converging to Verizon's mobile packet core. Who cares? That matters because that's exactly where your traffic anchors to an IP address. And what happens there is that's how you leave the mobile network out to the broader internet, and then perhaps to your AWS application. And if your application is hosted today in AWS, here in Vegas, you're probably connecting to US West 2, the Oregon region. But what you might not think about is Vegas to Oregon, that's pretty far. That's almost 1,000 miles. So wouldn't it be nice to cut out all of those network hops, where each of those hops, a buffer could be overfilled, resulting in unbounded delay. So let's cut out all those hops, cut out the non-determinism associated with the internet itself, and just bring that compute within the network. So now, all you do is at precisely that point where all of that traffic anchors to an IP address within the mobile network, that's where the compute sits. And we call this Verizon 5G Edge, and we've partnered with AWS to develop AWS Wavelength. And what you'll see today is it's all building on the concepts you know and love on AWS. We'll talk about that a wavelength zone is just an availability zone for those building on AWS today. An EC2 instance in the parent region, it's just an EC2 instance in wavelength. It's lots of similar concepts across the board. But I think one of my favorite parts about AWS Wavelength is we focus on optimizing the complexities of the network itself so you can focus on building your applications. Said differently, you might not have any interest in understanding how the mobile network actually operates, but that's okay. You only need to focus on building your application within the confines of your AWS environment and VPC. And we'll take care of the complexities of the network itself. And that just makes it easier for us as developers. And so one great example of why you might want to take advantage of these capabilities today, I built a little quick demo on the left side of the screen here. I said, you know what? Let's really think about how we can isolate the benefit of mobile edge computing. So what I'm not going to do is I'm going to take 5G and mobile edge computing and then race it against 4G in the parent region. I want to be more intellectually honest with myself. I want to say, you know what? Let's use 5G ultra-wideband, the fastest network, and then race the parent region against AWS Wavelength to isolate the benefit of the compute itself. What you're seeing here is a basic video streaming application. So I took my phone, I split it in half. That first half of the phone is essentially a camera facing a millisecond clock. I think it said something here like 624 and 50-something seconds. On the top half of the screen, you're seeing that same very stream of the millisecond clock itself. And how are we seeing that? Well, in both the wavelength zone, or edge, and the parent region, I have an RTMP module running taking care of that web streaming for me. And so the beauty of this millisecond clock example is you're going to isolate that end-to-end delay, because whatever the difference between the 2 millisecond clocks are the end-to-end delay. And then I can say, aha, the edge now saves me X. And so what you're seeing here is that without altering a single line of code, just changing exactly where I deploy that application, you're seeing a 33% increase in performance or 33% decrease in latency. And that's incredibly powerful, especially as you start to think about Industry 4.0 applications, because it's not just about one request and how much time you can save. If you were to add up all the savings from each of those requests, imagine what you can do with your business with that lower latency. And so as you think about these benefits here, lower latency, higher reliability, localized compute, we want to really unpack what each of those components really means. And to do so, let's start with the reference architecture, because we've talked a little bit about the application architecture, the benefits here, but how do you actually build on wavelength? And so for the architects in the room, what you'll see at the highest level, you have your VPC, your virtual private cloud, that logical isolation of compute resources. This isn't new at all. Today, you create subnets corresponding to a number of availability zones. That's how you build your applications today. But what if I told you that a wavelength zone, our mobile edge compute, is just abstracted as yet another availability zone? So much so that from the console, CLI, SDK, CDK, whatever you actually use to build, it's natively supported. It's just a dropdown. It's just an attribute. So all of that complexity, there isn't any anymore. You just leverage the console you know and love. So after you've created that subnet, which we all know how to do, now you need to think about, well, wait a minute. This is a wavelength zone within the carrier network. How do I actually expose those resources to my mobile and IoT devices alike? And that's what we call the carrier gateway. Sounds like an internet gateway, right? But it's a little bit different. And the reason why is it's not just exposing those resources to the internet at large, it's exposing them to the carrier network. So it's a little bit different. However, the process of doing so, exactly the same. You attach it to your VPC, you create a route table, that default route goes to the carrier gateway. Very, very similar stuff. But again, the reason that the carrier gateway and internet gateway are different has to do with something called carrier IP addresses. Today, when you have resources that you want to expose to the internet at large, you attach a public IP address. But in the case of the mobile network, it's not really a public IP address because it's exposed only to the carrier network. We call it a carrier IP address, and those addresses, rather, are coming from a pool of addresses that correspond to each of these geographies, each of the 13 wavelength zones that are generally available today. Again, today, 4 excluding GovCloud, 4 regions in the US, but now you have 13 additional geographies where you can deploy your application. Pretty cool, right? And what that now means is the carrier IP addresses are delineated for each of these wavelength zones, and you will attach it to your resources accordingly. And beyond that, that's wavelength for you. From an architecture perspective, it's pretty simple. However, where's the network intelligence story? Why does that matter? Here's why. We've now introduced 13 new geographies. So you're going to find yourself with the following scenarios. I'm an IoT device. I'm trying to do some near real-time analytics. And I've deployed my application geo-redundantly across each of these 13 wavelength zones. Well, today, I know that if I'm in Las Vegas, the closest wavelength zone to me is probably Las Vegas. But to that IoT device, it has no knowledge of that. And traditional modes of geo-IP-based lookups don't work because it's Verizon's carrier network. In fact, try it. Find the IP of your mobile address, pop it into a geo-lookup tool. It might say you're in Chicago or something like that. And so we need something else. We need network intelligence that's uniquely aware of your positioning, not geographically, but topologically within the network, so it can route you to the most optimal wavelength zone. Notice how I didn't say closest. I said most optimal, because it could depend on the parameters, your desired latency parameters, your desired bandwidth parameters, and beyond. And so we needed a tool to do that. And we're going to talk about exactly how network intelligence can be used to solve that problem, which is service discovery. But that's just the beginning. We also want to talk today about some even more exciting problem statements that we're starting to solve with our partner ecosystem around, well, it's great that we can route to the closest wavelength zone at any given point in time, but isn't that contingent on actually having deployed a workload to the right edge in a world where the number of edges continues to ever increase? Well, you got to get that deployment right on day one. But guess what? They're IoT devices. They're going to move around. So whatever works on day one probably won't be right on day two and definitely won't be right on day three and beyond. We need to think about workload orchestration, which to me is all about how does my environment change to accommodate my mobile device fleet on day two and beyond. And we're going to talk about each of those in the context of the very reference architecture you see on the screen. So let's talk about our Edge Discovery Service API. Our Edge Discovery Service API is an API that we developed here at Verizon that solves these problems. So we started to hint at, wouldn't it be nice if something told me at any given point in time that most optimal edge endpoint? Generally available today. You can find it on our Verizon 5G Edge portal. You can find it on our GitHub, github.com/Verizon/5G Edge tutorials. We have a getting started guide. But here's what it's doing at a high level. It's really just a service mesh or service registry. So the idea here is imagine a world that I'm on the East Coast today, low latency application. I've deployed in, say, Boston, New York City, Atlanta, Miami. These are all real wavelength zones. And when I deploy those applications, remember we talked about carrier IPs, the actual address exposed to the carrier network. I'm not connecting to the private IP address because that's only accessible within the VPC, right? I'm connecting to the carrier IP. So after deploying my application, however I might do so, I'll collect those carrier IP addresses that are exposing my application, perhaps my load balancer, the machine learning inference server, what have you. Take all those carrier-facing endpoints, and I'll populate them in the service registry. So Verizon now knows, aha, for this application called my cool machine learning application, I now have these endpoints that are now accessible. Great, that's step one. Now, as that IoT device or mobile device, I then invoke this Edge Discovery Service API to say, hey, I know I want to connect to my cool machine learning application, but which one? So as long as you specify that unique identifier corresponding to the service registry, it will then come back and say, I know exactly where you should be connecting to, and here's the carrier IP. And I'll add that this API not only supports the IP addresses, but you can pass ports, you can pass IPv6 addresses, you can pass FQDNs. Worth noting that IPv6 isn't supported today on Wavelength, but the flexibility around this API allows you to build for the future of edge applications. And it's incredibly easy to use. All you have to do, authenticate in, populate the service registry, and then a client, once authenticated, just needs one invocation of the Edge Discovery Service, and off you go to the closest edge. And I'll add that you could pass only one carrier IP to the service registry, or 13, or more. But Verizon, you're now offloading that undifferentiated heavy lifting of trying to figure that out yourself. You can imagine a world without this API that you could say, well, maybe ahead of time I know all of the different locations that I could be connected to, and then I could try to ping them locally on my phone, add them up, take the minimum. You don't want to do that. So this API abstracts away all that complexity, and of course removes that undifferentiated heavy lifting. And we're super excited to get your feedback on the API, but we also want to share a few examples of what we think this looks like today in the real world in the context of those two use cases I mentioned in terms of actually deploying the workload on day one, but orchestrating the workload at large on day two and beyond. So I want to start by talking about one of our partners. We've been doing a lot of work with Confluent, one of the leaders in data in motion, to really think about what Wavelength could look like for assets in motion. So you can imagine a world, perhaps a logistics or supply chain use case where you have some sort of truck or automobile that has critical telemetry data that needs to be streamed to the edge for real-time processing. But imagine a scenario where I started my day in Boston, so the ops team knew to deploy a wavelength zone in Boston. But I'm taking a little road trip south. I'm going a few hundred miles south, and the closest wavelength zone to me geographically is no longer Boston now. I'm closer to Washington, D.C. Or maybe I've gone all the way down to Atlanta or Miami. Well, now what you can start to do is the following. What if I wasn't only asking the Verizon Edge Discovery Service, hey, what's the closest deployed workload, which, again, is only Boston? What's the closest deployed workload, one? What's also the closest geography to me. That's another method that's available today in the Edge Discovery Service. So you're going to recognize this discrepancy, right? Well, now the closest wavelength zone to me is, in this case, we said Atlanta or DC, not Boston. You can then have that client intelligence to say, well, wait a minute, that's problematic. I want to act on that. So now what I'm trying to highlight is the Edge Discovery Service isn't just an information pool that you don't act on. You can now act on that information to say, aha, I've noticed a discrepancy. Hey, wavelength zones, can you add another workload for me in Atlanta so that you're able to persist that near real-time streaming capability? And so what we're trying to highlight here is this is just the start of how the Edge Discovery Service can actually be used to do more than just, hey, what's the closest wavelength zone to me? And so to learn more about this architecture, you can visit our GitHub page and see the automation right here. Essentially what we did, we extended Confluent for Kubernetes to the network edge. And we mentioned that as you think about AWS Wavelength, there are essentially 4 key services supported. You have your EC2 instances, EBS storage volumes, and then ECS and EKS clusters alike. So what we did is we took EKS, which is natively supported, added a self-managed node group in the wavelength zone, and ran our Confluent cluster there. And so the idea is, if I were to instantiate a new wavelength zone, you have 2 options. You could add a node group and deploy the cluster there, or an entirely new EKS cluster. Totally up to you. It would make sense, we believe, to minimize cost. You have all of these different wavelength zones. Imagine you're deployed to 5 different wavelength zones in all these geographies. Why have a bunch of control planes? If you've ever tried EKS today, EKS you launch in one of the, say, 6 availability zones in, say, US East 1. If you were to try to launch today the control plane in EKS on wavelength, it wouldn't work, because that's not what it's designed to do. Wavelength is all about that hub and spoke architecture. Parent region, all of your edges. So the idea here, control plane and region, and then as the Edge Discovery Service creates an intent-based approach to these incremental deployments, you just add a managed node group and extend your cluster accordingly. And again, this is just the start. If you want to learn more, reach out to us, reach out to the Confluent team. We'd be happy to share more about this Confluent for Kubernetes-based architecture. But this is just one example of network intelligence. As we think beyond data in motion, I want to talk a little bit about distributed databases. We've been talking about this forever, but we really get to see this in practice today with AWS Wavelength, with all of these different geographies. How do we care for these types of capabilities? And one of the things I've been saying a lot these days is that if you think about the infrastructure itself, AWS Wavelength, it's really good at providing that immersive experience by way of the localization of compute and by way of latency. But without a database out of the box, I mentioned the 4 services today available on Wavelength, how do I actually deliver personalized experiences? If I don't have any user profile data, if I don't have any telemetry data at my fingertips, I can't really provide that personalized experience for you. So it occurred to us, we need to do something about it. It's great that we have network intelligence now that tells us the closest wavelength zone. It's great that we have network intelligence that can inform what we do on day 1 and day 100. But we need to start to extend that feature set. And Confluent is one great example of extending data streaming to the network edge. But what about your more traditional database? So we teamed up with MongoDB to try to think about a number of these architectures. And we want to showcase one such example from an architecture perspective, and then position a pretty cool app that we developed that you can also check out on GitHub. Let's start with the architecture. So we've already talked about high-level reference architectures for wavelength, VPC, parent region subnets, wavelength zone. So for those of you less familiar with MongoDB Realm, it essentially was designed as a mobile database, the ability to write locally and then asynchronously update your parent cluster in Atlas, MongoDB Atlas. But we realized that you could actually virtualize, if you will, the mobile database itself, and run MongoDB Realm in one or many wavelength zones. And why does this matter? Because MongoDB Realm takes care of the complexity of both allowing mobile and IoT devices alike to both read and write, and Realm takes care of conflict resolution. So in the world of multiple edges, all coming together, remember, hub and spoke architecture, so multiple wavelength zones bubble up to the same region. That conflict resolution or recognizing discrepancies in writes is taken care of for you. So why might something like this matter, or what's a use case? There are a number, certainly in IoT, but a quick fun app that we developed back in the spirit of the Olympics, which wasn't too long ago. I was certainly a big fan of the swimmer Caleb Dressel, and it's always fun to build a computer vision app, take a picture of an athlete, and then say, aha, I know who it is. But wouldn't it be nice to also know, co-located with that machine learning inference algorithm, not just who it is, but maybe where are they from, or how many medals have they won, or what's their favorite food, or how many calories do they consume each day? Whatever that might be, you can now do that by co-locating the machine learning inference with the data itself in MongoDB. So if we can play a quick demo here, we'll see an example of Caleb Dressel being classified and characterized accordingly. There we go. See? Caleb Dressel and all of his 5 gold medals. So again, one such example of how you might use data at the edge. And I'll add that we also can tie this to the network intelligence. So if this is running in each of the wavelength zones, this is a simpler example. What do? Well, for each wavelength zone where the inference server is sitting, you take those carrier IPs, and you populate them in the Edge Discovery Service. And then when I want to actually conduct the inference itself, all I do is I ask, hey, Verizon Edge Discovery Service, where is this inference endpoint? And I'll add that the web app, if containerized or otherwise, the web app doesn't need to run at the edge. That can run in the parent region. Only the inference does. And this is, I'm hinting at some of the later topics I'm going to talk about, that in a world of containerization, when you have the flexibility to move workloads around, it's not edge versus non-edge. It's edge and parent region, or edge and other edge and parent region. It's a combination of how you leverage AWS Wavelength with the rest of your parent region, which is where things get really exciting. So we've talked a little bit about data streaming, databases. I want to talk about one other partner that I think is incredibly interesting as you start to think about not just day 1, what are you deploying, but day 2 and beyond as you think about performance monitoring. And so we teamed up with New Relic, not just to solve one problem, but 2 problems around both east-west traffic monitoring and north-south traffic monitoring. So for those of us less familiar with those concepts, think of the north-south traffic problem as, I'm an IoT device, which edge is the right edge? That's that north-south traffic link, getting to the cloud itself. But then you also have east-west traffic, which is within essentially your cloud environment. So it could be within a single wavelength zone, wavelength to wavelength zone to another availability zone. This gets complicated, right? Now, APM tools out of the box can absolutely instrument your environments, but you might not actually be getting anything useful, right? Because if everything to the performance monitoring agent looks the same, what's the difference between one availability zone and another availability zone? That doesn't usually matter because they're co-located within a few miles of one another, say US East 1A and US East 1B. But now, there's a pretty big difference now between, say, US West 2A and the Las Vegas wavelength zone. Wouldn't it be nice if that performance monitoring agent actually knew the difference between edge and non-edge? And we teamed up with New Relic to use their open source performance monitoring framework in Pixie for auto-telemetry using eBPF. And you can learn more by tuning into New Relic's session, Kubernetes Observability Use Cases, to check that out. But I want to talk today about the north-south traffic problem, because I think that's incredibly cool. Imagine the following scenario. Here at Verizon, if you check out our booth, you'll see we're running an example of crowd analytics, the ability to monitor the movements of large crowds in order to predict things like, where's the line with the popcorn stand with the shortest line? Or how do I navigate? Or are there clusters of traffic that are potentially dangerous? So fan analytics that involves ingesting tons of data from LiDAR cameras to predict anomalies and beyond. And so let's imagine that this use case requires a constant 5 megabits per second uplink. So New Relic today could monitor that link either for latency or bandwidth, and based on a certain threshold that you set today out of the box, you can set an alert. Maybe it goes to Slack and monitors your ops teams, and today you get that alert and probably nothing you can do, right? The link is congested, so you wait it out. But now, we can think about this a little bit differently. What if that webhook, so based on this alert, I'm not saying it to Slack anymore, I'm sending it to the Edge Discovery Service saying, hey Verizon, I'm a LiDAR camera. I was connected to the wavelength zone here in Vegas, But is that still the most optimal wavelength zone? Remember, or I'll borrow a phrase from the airline industry, the closest exit might be behind you. It may not be anymore that the Las Vegas wavelength zone is in fact the most optimal wavelength zone to support this use case. So by invoking automatically the edge discovery service, that client could reconnect, as you see on the bottom half of the screen here, could now reconnect to that most optimal endpoint. Isn't that cool? So now it's not just APM for the sake of APM at the edge. It's performance monitoring deeply integrated with network intelligence in a way that we haven't been able to do before. And I hope you can tell more broadly that across each of these, there's a central theme, and it's not just network intelligence is cool and it exists and you can use today. I think it's also about the fact that this is a shift. This is a fundamental shift in what intelligence is being used to orchestrate applications today. Container orchestration already exists. That's not a new concept. But today, decision-making, be it how we scale up, down, and sideways, usually happens from application metrics. The cloud computing literature often cites things like CPU utilization as that go-to metric when you're getting started, that, hey, that's what triggers that scaling behavior. But here at Verizon, we're starting to see a world where it's no longer about application metrics making those decisions. It's going to be the network. With the proliferation of 5G, the Edge Discovery Service API, and beyond, now the network gets to play a role in making those decisions on your behalf. So you no longer have to wait until a threshold is set. You no longer have to monitor all these capabilities. It's being done on your behalf. And we're super excited to share a few other examples that admittedly are forward-looking, but capabilities that we're starting to think about today. And there's two flavors. I want to start with an IoT flavor. We mentioned a little bit with the Confluent use case that we can start to reconcile discrepancies of, hey, I know where I was deployed, but now I've actually moved, and that new geography no longer has an edge that I'm currently deployed to. Let's think about it like this. Imagine you have an IoT device, and they're connected to Verizon ThinkSpace. This is our IoT platform. So this is B2B use case. I own the IoT devices. They're tracking some sort of asset. Great. There's an API that ThinkSpace provides that tells you the general geolocation of those IoT devices themselves. So let's get a little bit smarter about the use case that we talked about with Confluent, about sort of deploying that new workload in advance of when that device actually needs it. Because what you can do now is say, I know where that device was now. I know where it was 15 minutes ago. I know where it was 30 minutes ago. Wait a minute, I'm starting to see a trend or a path. I can start to predict with some level of confidence that, wait a minute, I know where this is going. They're going to be closest to the DC wavelength zone in maybe 15 minutes from now. So I can schedule that scaling activity in advance of when the IoT device actually arrives. So you don't have to wait for that instance to boot up or that node group to become ready. It's already there for you. So that's a lot more intelligent than just general predictive autoscaling based on a metric. You have all this flexibility to start to tie together not just network intelligence and network metrics, but application metrics, device metrics, network metrics. Bring them all together to tell a much more complete, holistic, and accurate story about how your application should behave. So that's one example. But in the nearest of terms, I think the second example is incredibly exciting, but critical. Everything we've talked about here, at least the initial use case for the Edge Discovery Service, implies that there is a DevOps engineer who's responsible for figuring out, oh, OK, I have these 3 carrier IPs and these wavelength zones, and I'm going to go populate my service registry accordingly. But we don't want to do that manually. We all know that our environments are ephemeral, ever-changing. We can't rely on manually extracting carrier-facing endpoints. Same analog for public IPs. We would never expect an ops team to be responsible for manually sifting what IP addresses are exposed and populating some service mesh. Something or someone has to do it for me. So one of the areas we're starting to explore is using Kubernetes for what Kubernetes does best, automation and orchestration. More specific example here for you. Admission controllers are this beautiful concept that many of us are familiar with that basically can watch for a specific resource and an action against that resource and do something about it. Validate the creation of the resource, change it in some way with mutating and validation admission webhooks, respectively. So why do we care? We care because now we can monitor for node ports and load balancer resource creation, updates, and deletes. So that we can now say, I know at any given point in time what day one looked like when I first deployed those carrier resources and populate the Edge Discovery Service. But if anything changes, I'm not responsible for it. Verizon Edge Discovery Service with Kubernetes will take care of it because the admission controller is always watching and listening for changes. So now with these two use cases, you not only can use the Edge Discovery Service, but it's being invoked it's being invoked automatically. New deployments are being triggered automatically. Those new deployments are tied back to populating the Edge Discovery Service automatically. It's an end-to-end network intelligence-based value chain that has been entirely automated. And we're super excited about this future because I think that if there's one thing to take away here, it's not just about the edge computing infrastructure. It's not just about databases or database in motion or the IoT devices and new capabilities. It's not even just about network intelligence. Rather, it's about how all of these capabilities come together to really reshape and redefine what it means to actually deploy workloads to the edge. It's no longer a yes or no question to edge or not to edge. Rather, it's how you start to think about the almost limitless permutations of what the edge can mean and where you end up deploying, and of course, what that means for your business. So I hope this inspired you to maybe get started with AWS Wavelength. And if you're as excited as I am about the mobile edge, there are a number of ways that you can get involved. And I'll give you a few examples of what that might look like. Here at Verizon, I lead our developer relations efforts. And it's really important to me that we make it easier than ever to get started, not only with the infrastructure here at AWS, but also our APIs. And we have a number of ways you can do so. One great way, check out our 5G Edge blog on Medium, always updating new content, tutorials, reflections from our partners. You can check out our developer newsletter, comes out every single month. You can go to verizon.com/5GEdge to learn more. But equally important is our immersion days, where you can get hands-on experience with everything we talked about here, the reference architectures, and also build that Caleb Dressel application we saw. And so across the board here, we want to be your trusted partner for your edge enablement journey, and we can't wait to hear from you.
I think Robbie's right. We're really excited about building this ecosystem, and what you said about us all, you can hold the conch. You got it. You got the shell. It's about us all kind of coming together. The reality is that while Robbie and I and the entire Verizon team are really excited to get going, the community is the ones who are going to kind of beat this up and help us kind of work together to propel the future. So ideally, we want to get your hands on your keyboards, kind of bumping along this with us and providing the feedback. So we would love for you guys to all get encouraged and come along in this journey. In addition to that, Robbie and I, just in case you want a little bit more of the excitement, which is possible, as you did a great job, man. We're going to be over at the Telco Lounge right after this, around 11 o'clock. If y'all want to come play around with some robots, go check some things out, talk to us more about the mechatronics or the actual engineering effort. If you want to talk to Robbie about how you can get involved, if you want to know more about any of this stuff, we'd love to come host you at the Telco Lounge. So take a screenshot, come on along, meet us over there. We can share a cup of coffee. You can also reach out to, I'm gonna offer it up, dude. You can reach out to us on email. It's first.last@verizon.com. You can reach out to us on LinkedIn. Are you on Twitter?
I'm on Twitter, Robert Belson.
I'm not on Twitter. I do not tweet. But anyway, we'd love to get in contact with you. The reality is we're really excited about the future. We're really excited and grateful for our continued partnership with AWS. We're excited that you decided to spend a portion of your morning with us here today. Hopefully you have learned a few things along the way. We'll catch you guys around the floor, but thanks for coming. Have a great afternoon. Yes. Woo!